algebraic concepts that are useful for business calculus. That's what I would like to cover in this pencast. There are a lot of algebra mistakes that people tend to make, or things people don't remember, so I would like to try to address them as briefly as possible. But first, let's go over the fact that 0 over any number equals 0, because a times 0 is 0. However, if you take a number like 9 divided by 0 or a divided by 0 and say, what does that equal? Well, no number times 0 equals a, so this is undefined. So functions are undefined when we have the denominator equal to 0, which brings our second topic up, which is domain, which is what can you substitute into a function. And this isn't so bad if you can remember that you can't divide by 0, and you can't take even roots of negative numbers. As an example, f of x equaling 1 over x. This is our most basic rational function. It's undefined when x is 0, so x cannot equal 0. That means that you can substitute any value you want for x except for 0. In interval notation, that means we can start at negative infinity, which we never include, go up to 0, but we can't include 0, or it could be a positive number, somewhere between 0 and infinity. Another example of domain would be f of x equaling the square root of x minus 4. We can't take the square root of a negative, so what we want is for x minus 4 to be greater than or equal to 0, and then we just simply solve for x, and we get that x must be greater than or equal to 4. We can write that in interval notation. It starts at 4 and includes 4 up to infinity. Exponents are another topic that are quite useful, so I would like to go over just some of the basic rules here, mostly with negative exponents and fractions. So the first rule is that anything to 0 power is 1. Next rule to remember is that you can distribute an exponent over a product or a quotient. I'll just put these together. But you cannot distribute, that's a not equal, over a plus sign. Similarly, you can't distribute over a negative sign, a subtraction. So this is a not equal. You can't distribute over a plus or a minus, but you can over a product or a quotient. Negative exponents. All that means is reciprocal. So we're simply taking the reciprocal of a number. An example is that x to the negative 3, all you do is cover the negative up and take the reciprocal. Another example like this with numbers, 3 raised to the negative 2, if we drop the negative and take the reciprocal, we get 1/9. Next exponent rule has to do with radicals. So we have a fraction as an exponent. So a fraction as an exponent is the same as a radical. X to the 1/2 power is the same as the square root of x. We never write the index of 2. X to the 1/2 is a way to write that. Similarly, if we had x to the 1/3, that's the same as the cube root of x, and x to the 1/4. Now the exponent isn't always 1 over n. We might have a number. So this is our next rule. This will be rule number 5. If you have a raised to the m over n, that's equal to n, the nth root of a raised to the mth power. And it also equals the nth root of a, the whole thing raised to the mth power. For example, x to the 2/3 can be written as the cube root of x squared. It can also be written as the cube root of x, the quantity squared. It would depend on the numbers that you're given. Another example, you have x to the -3/5. First thing I would do is write that as 1 over x to the 3/5 power, which is just a radical. It's the 5th root of x cubed. And that's how I would write my answer for that.